Alright, so this is your Chapter 11 pre-test review. So my suggestion was that you print out that pre-test or you look at it on your iPad and show all of your work on a separate sheet of paper. So you should complete the first form. It says Test Form 1B, pages 270 and 271. That would be the first number 1 through 13. You'll finish those on your own. And then I'm going to pick up with Test Form 2A, page 272, just like we normally do in class. I'm going to do each of these step by step for review, and you will also copy these down on your separate sheet of paper so that when you turn in your pretest, I can see that you've done the whole thing. If you have any questions on the pretest, we will go over them on Zoom, just like we do for homework questions. So number 1 says, in the figure at the right, P is parallel to Q, so these two lines are parallel, which makes T the transversal because it crosses two lines. It says use the figure for exercises 1 and 2. Well, let's review these angle pairs a little bit before we get started. These angles and these angles are outside the parallel lines, so we would call those exterior angles. These angles are between the parallel lines, so we would call these interior angles. So we always start out by labeling the angles either inside or outside, interior or exterior. Then you can go with pairs. Alternate exterior would be 2 and 6 because they're on opposite sides of the transversal and they're both exterior. 1 and 7 would also be alternate exterior. Then you can move to the inside. 3 and 5 are alternate interior, and 4 and 8 are alternate interior. Now, any type of alternate pair, either alternate exterior or alternate interior angles, are congruent, which means they're equal. The last set of angle pairs we had were corresponding angles, and this is where I suggested that you draw two foursquare chords. And the players in the same position are corresponding angles, and they are congruent. So player 2 and player 8 are in the same position. They're corresponding, which means they're congruent. 3 and 7 are in the same position, so they're corresponding and they're congruent. Same with 1 and 5 and 4 and 6. So now let's look at number 1. Number 1 says the measure of angle 5 is 128. And it wants me to find the measure of angle 2. Well, first you have to ask yourself what type of pair are 2 and 5, if any. Well, 2 is here and 5 is here. 2 is exterior, 5 is interior. So they're not alternate exterior, they're not alternate interior, and they're not corresponding because they're not in the same player position. Well, I can relate angle 5 and angle 6. If I look at angle 5 and angle 6, they both make a straight line, which means they add up to 180. So if I say the measure of angle 6 plus 128 equals 180, I can solve for the measure of angle 6. That way, I can compare angle 6 and angle 2. So I'll do 180 minus 128 from both sides to find angle 6 is 52. Well, if I know what 6 is, now look at 2 and 6. They're both exterior, and they're on opposite sides, so they're alternate exterior. I can say the measure of angle 2 equals the measure of angle 6 because they are alternate exterior angles. So angle 2 has to be 52 degrees. Number 2 is asking about the same picture. It gives me angle 6 is 3x minus 13, and angle 8 is 2x minus 5. What's the value of x? So I have 6 and 8. Well, they're on the same foursquare court completely, so they're not in the same player position. They're not corresponding. I have one exterior and one interior, so I don't have alternate interior or alternate exterior. So my other options would be supplementary. Well, they don't share a side to make up a straight line, so they can't be supplementary. Can't be complementary because I see no right angle marks. What about vertical? Well, they make these two V's. They're across from each other. They are vertical. So we know that vertical angles are equal. So since they're vertical, I'm going to set the measure of angle 6 equal to the measure of angle 8. 3x minus 13 equals 2x minus 5. I'm going to get all my x's to one side. And all my numbers to the other. So you get x is 8. Alright, number 3. The measures of the angles of a triangle are in the ratio 4 to 5 to 9. What are the angle measures of the triangle? Well, we know all the angles in a triangle add up to 180. I also know that 4 plus 5 plus 9 is not 180. Remind yourself that we had steps for these in our notes. Ratios are always written in simplest form, so I have to unsimplify. First, I know that everything adds up to equal 180. Second, if I'm working backwards, I'm unsimplifying. I have to multiply each one by the same number, x. And if I know they add to 180, I have to add them all together. 4x plus 5x is 9x, plus another 9x is 18x. I'm going to divide both sides by 18 to get x is 10. But it doesn't ask me what x is, it wants to know what the angle is. So I'm going to say 4x, 5x, and 9x, which becomes 4 times 10, 5 times 10, and 9 times 10. Now if you check and you add all of those up, you get 180. And you also see that those are the measures of the triangle. 40 degrees, 50 degrees, and 90 degrees. Number 4. The measures of the angles of a triangle are in the ratio 3 to 4 to 5. Well, first thing I notice, 3, 4, and 5 do not add up to 180. So I'm going to start with the same steps I had before. I know that they have to add to 180. I have to multiply each of them by the same number and add them together. So I'm going to work through that. Combine your like terms. 3 plus 4 plus 5x gives me 12x. I have to get the x by itself by dividing both sides by 12 to find that x is 15. Then I have to plug each of them in. 3 times 15, 4 times 15, 5 times 15. So 3 times 15 gives me 45. Add another 15 to it, 60. Add another 15 to it, 75. So I see that these are all smaller than 90 degrees, therefore it's acute. And there's only one option with acute there. It would be acute and scalene. If none of the angles are equal, then none of the sides are going to be equal. So remember, acute, all of the angles are smaller than 90. Right, 1 equals 90. Obtuse, 1 is bigger than 90. And by side, scalene, no sides are the same. Isosceles, 2 sides are the same. And equilateral, all 3 sides are the same. So number 5, classify the polygon shown. Well, if I count the number of sides, I see there are 1, 2, 3, 4, 5, 6. 6 sides. A 6-sided figure is called a hexagon. Remember, I suggest that you know all of the sides up to at least 10. Those are listed again in your notes. Number 6, find the sum of the measures of the interior angles of a polygon with 6 sides. So So I'm going to write out the equation. Sum of the interior angles is equal to n minus 2 times 180, where n is the number of sides. They tell me that my n is 6. So I get 6 minus 2 times 180. 6 minus 2 first. 180 times 4 gives me 720 degrees. Number 7. Find the coordinates of C prime if triangle ABC shown on the coordinate plane is reflected over the y-axis. So first, I'm going to write down the coordinates of C. If I look, C is at -2, -1. And I need to reflect over the y-axis. Well, we said before, when you reflect over the y-axis, this is my y-axis, going from one side to the other, or one side to the other, your x changes signs. So reflection in the y-axis, if I wrote this out as a formula, means your xy, x becomes the opposite sign. So my x was negative, it's now going to be positive, and my y stays the same. Number 8. Triangle TUZ has vertices T, 2, 0, U, 1, -2, and Z, 2, 1. The triangle is rotated 90 degrees clockwise about vertex Z. What are the coordinates of U prime? So again, we could graph this to help us out a little bit, since we don't have a picture like we did in number 7. So I'm at 2, 0, 1, -2, and 2, 1. Oops, this is C. Okay, so I'm rotating about vertex Z. This one up here is my point of rotation, so that one is not going to change. And I'm going 90 degrees the way the clock turns. And they're asking me about U. So this is the one that I'm turning 90 degrees about this point. Okay, so let's also write down our U is at 1, -2. Well, if I'm turning it 90 degrees, I need to move one quadrant, okay, clockwise, the way the clock turns. So that means that my U is going to end up somewhere up here, because I need to move, one whole quadrant. 90 degrees about this point. So I could do this one even by process of elimination. I could see that it can't be F, because point F gives me -1, -2, which is down here. Can't be J, because that puts me here. So now I'm left with G. It's either going to be -1, 2, or -1, 1. Remember that this is something that is a congruence transformation. If this is my original point, it cannot become -1, 1, because therefore my triangle would get smaller. It has to be -1, 2, because it's going to keep the same size of my triangle. It's in the correct quadrant. I knew it had to be up here, moving 90 degrees, one full quadrant. And it has to keep the same size. So it cannot be -1, 1. It will get too small. So I'm left with option G. U prime is at -1, 2. All right. Number 9. Last page of your pretest here. Number 9 says, triangle XYZ has the given vertices. Okay, so I'm going to list these out. X is at 6, 0. Y is at 4, negative 4. And Z is at 8, negative 4. Okay, and the new ones, the image, X prime is at 6, 0. Y prime is at 4, 4. And Z prime is at 8, 4. Which statement best describes the transformation? So let's see how our points changed. Well, if I look here, my X and my X prime, it didn't change. It looks exactly the same. Okay, move on to the next one. 4, negative 4, and 4, 4. Well, if I look here, this went from negative to positive. It changed signs. And the last one, 8, negative 4 became 8, 4. This changed signs. Well, remember, whatever you do to one point, you have to do to all of them to keep them being congruent. So if I said I changed the sign of 0, 0 doesn't have a sign, so by changing the sign, there is actually no change. So I could say that there is a change of sign. So I could say my xy, well, in all of these, this one stayed the same, this one stayed the same, this one stayed the same. The x doesn't change. But we said the y changed signs. The y changed signs. Even though you don't see it in the 0, the y changed signs. So we have to figure out what type of transformation is that. Well, let's look at our options. Translating 4 units down. Well, if I moved 4 units down, down is a y direction, so I would subtract 4 from the y. Well, from here to here, no subtraction, no subtraction, no subtraction. Can't be a translation. So it can't be A, and it also can't be B, because I'm not adding anything. So it's got to be a reflection. Reflection over the x-axis or reflection over the y-axis. Well, remember, when you reflect in the x-axis, this is your x-axis, you're moving from top to bottom, or from bottom to top, your y is what changes signs. So this would be reflection in the x-axis. All right, number 10. Number 10 says triangle QRS has those vertices. Okay, so let's list them out, just like we did on the last one. Q is at 0, 0. R is at 2, 0. S is at 2, 3. The triangle is translated 3 units up and then reflected. Okay, so we're translating 3 units up and then we're reflecting, and it's ending with 0, 3, negative 2, 3, and negative 2, 6. So if we're translating 3 units up, that means we're adding 3 to the y. Well, here to here, yeah, we added 3. Here to here, we added 3. Good. Here to here, we added 3. And then it says reflecting in the y-axis. Well, reflection in the y-axis means the x changes signs. Changing 0 doesn't change anything. This went from positive to negative, positive to negative. Okay, cool. Which statement explains why the triangles are congruent? Well, both triangles have right angles. I have no information about angles at all, so I would throw out letter F. Letter G, the side lengths are the same measures. Well, if all the side lengths are the same measures, then yes, they are congruent, but that doesn't really describe what I have. They didn't list or give me any of the side lengths. So that one, although true, does not describe what's going on in our problem. Letter H says the ratios of the side lengths are greater than 1. Well, if the ratio of the side lengths is bigger than 1, that would mean our scale factor is bigger than 1, which means our coordinates or our shape gets bigger. Well, if it's bigger, it's not congruent. So the last one, letter J, translations followed by reflection, which is exactly what I did. I translated and then reflected, preserve shape and size. That's true. Translation, reflection, and rotation are all congruence transformations. They keep the same shape and the same size. So that one is true, and it's describing what's going on in our picture. Number 11. The triangles shown are similar. Which series of transformation maps ABC on to DEF? Okay, well, if I look, ABC is much smaller than DEF. So I know that I'm going to have some sort of dilation for sure, because it goes from something that's small to something, that's bigger. So it does have an enlargement. Okay? That means I can eliminate option A and I can eliminate option D. Okay? Because neither of those have dilation. Well, if I look at this, it really looks like I just took this figure and I moved it to the right. The orientation is the same, nothing is flipped. So if I'm moving something left to right, that would be a translation, because I'm moving it left to right or up and down. So therefore, option C, a translation followed by a dilation, would best describe my picture. Number 12. Charlotte is creating a triangular pennant with geometry software. The base of the pennant measures 550 pixels. Let's draw our pennant. Base is 550 and the height is 275. Charlotte resizes the pennant, keeping the aspect ratio constant. So now the height is 165. Got a little bit smaller there. What is the scale factor of dilation, and what is the base of the new pennant? Okay, so I have to figure out, did it get bigger or smaller? Well, I see that this got smaller, so my scale factor has to be smaller than 1. So I'm going to do 165 over 225, because these are in the same position here. And 165 over 225 is going to give me a number that is smaller than 1. My scale factor would be 0.6. Okay, so now I can figure out how to get from here to here. Well, I know whatever I do to one, I have to do to all of them. If I did 275 times 0.6, I got 165. So now I'll do 550 times 0.6 to get my new base measure. And my new base measure, 550 times 0.6, is 330 pixels. So this one has two parts, 0.6 as my scale factor and 330 pixels as my other dimension. Make sure, especially on the test, that you're answering every part of each question. Number 13. Let P be -6, 4, a point on the rectangle PQRS. What are the coordinates of P prime if I'm dilating by a scale factor of 3/8? Let's say equals. Okay, well, just to review, whenever we do a dilation, we multiply each of the coordinates by the scale factor. So I'm going to change this to -6 over 1 times 3/8, comma, 4 over 1 times 3/8. Okay, so I get -18 over 8 and 12 over 8, which you could reduce as a fraction on your pretest. I wrote it as decimals, that's fine as well. But those would be my new coordinates. Number 14, determine whether the figure shown has rotational symmetry. If it does, describe the angle of rotation. So this is where I suggested whenever you're talking about rotational symmetry, you actually take your paper and you turn it. Well, if I count here, there are 1, 2, 3, 4, 5, 6, 7, 8. There's 8 little stems with circles on the end, and they all look exactly the same. Well, if I rotate it just one small turn, it looks exactly the same. So I would say yes, it has rotational symmetry. Now, since all 8 of them are the same, and if I turn the figure all the way around, I've turned it 360 degrees, I have to figure out how much I'm turning it to just turn it from one circle to the next. So I'm going to do 360 divided by 8, which is 45. So every 45 degrees, I will see the exact same figure. So at this point in time, your pretest should be completed. Again, you did pretest form 1B on your own. We just completed pretest form 2A together, and you should have all of your work on a separate sheet of paper. You will upload that work onto the appropriate folder on schoolwork, and if you have any questions, we can go over it on Zoom.